Hi everyone. Good morning. Okay, we're starting on aldehyde and ketone reactions, and you'll have a quiz on Friday. So this gives you all week to learn this stuff. Um, Hold on because it does get hard. You really have to work on this. It is not automatic. It doesn't come easily, and you really do have to use your class time wisely this week. Um, Pretend you're in college, pretend you went to one class and you have to master this, and it's all up to you. Use each other. Work together. I really do recommend flashcards with maybe the name of the reaction on one side, and also the reactants, so the name and the reactants on one side, and then the products on the other side. Individual flashcards too, helping you to pick out what an aldehyde and a ketone reaction look like in terms of what the products are. So you're going to be looking at some new molecules that are products. You have to be able to identify what those are. Okay. So just to review real quickly, upper left-hand corner here, we have an aldehyde in shorthand. And remember, this R is the rest of the molecule. And you'll remember from the beginning part of this chapter, or the beginning part of the aldehydes rather, that we have a double bonded carbon at the end of our chain. And then of course we have a hydrogen out there because the carbon is the last carbon in the chain. So double bonded oxygen and the carbon, this is called a carbonyl group. Okay, so it's carbon eel, YL. It's a carbonyl group. Okay, now this guy right here is a carbonyl carbon. Okay, now you get over here to the ketone, and it's really no difference except for instead of being at the end of the chain, your double bond is in the middle of the chain somewhere, and you have more of the molecule out to the other side. You can't see the carbon right here, but it's actually in the center. So this is one part of your molecule, and then the other part of the molecule. Okay, so just keep those apart. Make sure you don't confuse them. This guy down here, yeah, that's an alcohol. Back to the easy days of an alcohol. The alcohols we'll be dealing with are for the most part, primary, but you will run into a secondary every now and then. So just keep your eyes open. Now, this is something new, as you can tell. This is called a carboxylic acid, and this is a new functional group right here. And so you can see this is our bond, and then we have carbon, oxygen, and then we have a hydroxyl. So you might say to yourself, well, carboxylic acids, I don't know any of those, that's new. Well, actually it's not so new. Acetic acid is a type of carboxylic acid, and acetic acid, you'll recall, is the active ingredient in vinegar. So you guys probably remember from chemistry, this guy right here, this is an acetate ion. And of course, when it bonds with a proton, it is going to form that stuff right there, which is acetic acid. So acetic acid is a carboxylic acid. Now, a couple of different terms. This thing right here is called not a carbonyl group, but a carboxyl group. Okay, so when you have this alcohol at the end of this carbon right here, this is actually called a carboxyl group when you add this on. This is not a carbonyl carbon anymore, it's a carboxyl carbon now. And for the most part, I get that right. I have to think a lot before I say it though, because sometimes I get confused, but you should know the terminology. This is our carboxyl group, carboxyl carbon. This is a carbonyl group up top here, and a carbonyl carbon. So keep those straight and make sure you know these functional groups and these molecules here. Okay? Now, a couple of other things that you need to be aware of. When we have reactions, we're going to get a couple of new molecules, which are actually kind of tricky. And so I'm introducing not a full acetal to start with or a full ketal to start with. I'm introducing halves. So hemi means half, like hemisphere, eastern, western hemisphere, northern, southern hemisphere. So this is half of something that we call an acetal. This is half of something that we call a ketal. Okay, there's no difference here except in a hemiacetal we have a hydrogen off of our central our carbon where we have the hydroxyl and this thing right here, which is an ether. Over here, though, on the hemiketal, our chain will continue. So we have two ends of the molecule here as opposed to one in here with just a hydrogen. Now, what you're looking at here on the top, this is an ether. And this is an ether. So this might be methoxy, it might be ethoxy, propoxy, whatever you want to imagine is there. And this thing right here, of course, is a hydroxy or a hydroxyl group. Your central carbon then has two parts of the long chain. It's got an ether off of it and it's got an alcohol. Here you have one part of a chain with a hydrogen, an ether off of it, and an alcohol off of it. So it gets a little bit tricky here. I know you haven't seen this type of abbreviation much, but it's actually not too bad. All you're looking here at is a tetrahedral type of formation, and it's trying to show you that this is coming towards you and this is going away from you. Okay? Now, I don't expect you to immediately look at that and to know it, but it is a good idea to kind of have the formation in mind. Now, when we do reactions, I'll typically take the pitchfork approach, which is this. Okay, the pitchfork approach, this is only half of a pitchfork here. So what we'll have up here is a hydroxyl group. Here's that carbon in the middle. Here's my ether down here. And then this is the rest right here, the rest of my molecule. And then on this side, if I have a hydrogen right here, then what I have is a hemiacetal or hemiacetal. If, on the other hand, this hydrogen is not here and this chain extends, then I have a hemiketal. So I would have the rest of the molecule out here. So essentially what we have is we have an alcohol off of one carbon, and off the same carbon we have an ether. So that's half a hemiacetal, or half an acetal and half of a ketal. Okay, now the next slide gets a little trickier, but I'm going to show you a couple different pictures so you don't get too confused. So these top guys you've seen before, okay? And here are the bottom guys. These are the full acetals and the full ketals. Again, these are products that you're going to see in these reactions. Now, the interesting thing here is that we have two ethers. Okay, so this is an ether group and this is an ether group. Okay, now this is an acetal. So what we have here, if you imagine this is your central carbon, remember the pitchfork I drew? Here's our pitchfork. Okay, now this is an acetal, so right here we'd have a hydrogen. Here is our carbon. Here is the rest of our chain, and then up here, this is an ether, and then right here, this is an ether, and the corners are where the oxygens are, okay? If you look at the hemiketal to the ketal, then all you're looking at here is instead of an H over here, you now have an extension of that chain off of that carbon as its fourth bond. So again, get rid of this dude, and your chain extends, and there we have it. Okay, so if you know the basic format, you'll know what to look for in these. Okay, so what I did was I just took a picture and put it on the PowerPoint. This was not easy, it drove me crazy, so I hope you appreciate this. Okay, I have just a few blurbs up here for notes. I drew the acetate ion a couple different ways. You can put the formula that way or that way. So you're probably wondering when you were in honors chemistry why you had to learn it two ways. Well, because it is a carboxylic acid, and many times you're going to see when you have the acetate bonding with the hydrogen, you're going to see the structure written this way. Okay, so it can be written this way, but it's also written this way. Now, combustion reactions. These are the easiest to learn, but they're probably the easiest to forget. When you have an aldehyde and a ketone, you will not have a combustion reaction. Most aldehydes and most ketones do not burn. Okay, so that's a good thing because we have one less reaction to balance, and I know you guys love to balance those reactions. Okay, so the second reaction here is called oxidation of an aldehyde. Now, you have to go back because in the last chapter, what we were looking at was if we had oxidation, we were looking at either the oxidation of a primary or a secondary alcohol. So if we have oxidation of a primary alcohol, that's where we first introduced aldehydes to you. So oxidation of a primary alcohol gives us aldehydes. Okay, now, here's the problem. Oxidation of a primary alcohol to an aldehyde, essentially what we were doing was we were taking off two hydrogens. We were taking off two hydrogens, so minus two hydrogens. When that aldehyde continues to oxidize, however, what happens is we're actually adding in oxygen. So the second part of this is going to be a carboxylic acid. This is what's going to be formed in its addition of an oxygen. Now, here's the confusing part. What actually happens is this oxygen kind of puts itself in here, and the mechanism we're not going to go through, but this oxygen inserts itself right here. We have some unbonding and we have some rebonding, and then what we have at the end here is a hydroxyl group. When you put that hydroxyl group on, then what you're going to see is a carboxyl group, and you're going to see a carboxyl carbon. Okay, so that's what's happening. The same things are going to be written over the arrow for oxidation, but you really have to look here because you don't want to look at this aldehyde and go, oh, we're removing two hydrogens, because you're not. This is what is formed after the alcohol oxidizes. Further oxidation is going to give you a carboxylic acid. So this is what it looks like in skeletal form. Please draw this out. It's so much easier to tell what you have when you draw it out. Here's where your oxygen came in. Now, you don't have to name these yet because we haven't gotten there. This is, we're going to get here pretty soon, but you can see that there's 4 carbons out here. So there's a couple ways to name this. I'm not going to go into it right now, but it works the same way as everything else has worked up to this point, okay? So oxidation of an aldehyde. An oxygen atom is added to the hydrogen atom attached to the carbon right here, so that carboxyl carbon, okay? Okay, we do not have oxidation of a ketone. We do not have oxidation of a ketone. We just have oxidation of an aldehyde, okay? Now, the opposite of oxidation in chemistry is called reduction. The opposite of oxidation is called reduction. So this is reduction of an aldehyde. This is paired with the first reaction, and what you can see here is this. When we have an aldehyde, and remember, this aldehyde is made from the oxidation of an alcohol, and in this case it's going to be a primary alcohol, okay, we're going to get this. Okay, so once again we have an alcohol oxidizing, and we are going to get this aldehyde right here. So hopefully you see the aldehyde. Now, a reduction reaction is when we're going to add those hydrogens back in. So you're going to see the hydrogens right here. Typically you're going to see a metal catalyst up on top of the arrow. So when you add these guys back in, you actually end up forming, oh my gosh, a primary alcohol. So this is the reverse of the oxidation of a primary alcohol, and you're going to get a primary alcohol carbon at the end. Okay, as you can imagine, what's going to happen next is if we have reduction of a ketone, instead of this double bonded oxygen being at the end here, it's going to be in the middle, and we're not going to get a primary alcohol, we're going to get a secondary alcohol. So the better you know the reactions that came that were in the last chapter, the better off you're going to be. You may need to review those. Okay, this is reduction of a ketone, and as I just mentioned, it's the same thing that you have above. All right, so here's our ketone. Okay, here's our carbonyl carbon, our carbonyl group. The double bonded oxygen is at the center of the chain, somewhere in the center anyway. So reduction, opposite of oxidation, so we're adding back in those hydrogens, and then we end up in this case with a secondary alcohol. I'm going to stop right here because I think I'm probably running out of time, and we'll do the back on the second little vodcast. Okay? So pause this if you're still writing stuff down.